Hello everyone. Today we're going to start lecture 15, the last lecture of the discipline Automated Planning of Wares of Light Industry. The topic of today's lecture is Directions for Improving CAD Software for Clothing. And content of today's lecture consists of several questions. We start with introduction, the state of fashion of recent years, and then we go to the first question, the main direction for improving CAD software for clothing, and the second question, CAD's technology in the production of clothing. And goal of today's lecture is to define the future of fashion industry based on automation of technologies. And this lecture you will find sources to study and short glossary. And before we start, I would like to think about some questions related to what you studied before in the previous 14 lectures of this discipline. So the first question is, what is the reason of developing CAD for fashion industry? Second question, what stages of production of modern clothes do you know? Third question, how they connected to CAD systems? And fourth question, name some of the CAD systems related to creating production patterns or flat patterns. So please think about these questions and we will start our lecture. As you know, fast fashion, speedy supply chain quickly caters to new trends. You know that fast fashion is the main trend of the light industry last maybe 10 years. So I would like to show you an example of a fast fashion retailer, Zara, owned by Spain-based Inditex company. And then they can get a piece of apparel from a design workshop in Spain to a display rack in a Manhattan store in 25 days. So it's quite quickly provided process. So for example, day one, a designer in Spain sketches a new piece of clothing with input from store manager on the latest trend. And then day 2 to 5, a pattern maker creates a prototype. Day 6 to 21, fabric is cut. 8,000 new pieces, coats, dresses, etc. are sewn together at a nearby factory and are made ready to shipment. Then day 21 to 24, apparel is driven to a distribution center before heading to Barcelona to be flown to Zara stores around the world. And last 25 day, new items arrive in Manhattan and are put on display before opening. So as you can see, modern fashion industry have lots of challenges related to competition. And the leader in this industry, Zara company, makes the process, the chain of production and distribution in 25 days. So it's very quickly made process. As an introduction, I want to show you some state of fashion of 20 years. made by analytical company that gather all the trends in fashion industry. Company's name is McKinsey & Company.
Downward economic movement and destabilizing forces will create a more cautious mood. With a possible global economic slowdown by 2020, companies will start to look more aggressively at ways to boost productivity.
India will become a focal point as its manufacturing sector grows and middle-class population continues to swell. Fashion companies must redouble their efforts in this highly challenging and upwardly mobile market.
Companies will need contingency plans for a potential shake-up of the global value chain. Trade tensions and uncertainty could negatively impact the apparel trade, but positive opportunities could also emerge from new trade agreements.
The lifespan of the fashion product is becoming more elastic. As pre-owned, refurbished and rental business models continue to evolve, more consumers will turn away from the permanent ownership of clothing.
Younger generations' passion for social, political and environmental issues has caused brands to become more purpose-driven. In many markets, fashion players that take a strong stance on these causes and issues will be rewarded.
On mobile, the gap between discovery and purchase has become a pain point for an increasingly impatient consumer. Fashion players will bridge this gap through shorter lead times, improved availability, and new search technologies.
After having personal data owned and handled by businesses, a more distrusting consumer expects companies to reciprocate with heightened levels of transparency. Honesty and openness around value for money, creative integrity, and data protection will grow in importance.
Traditional brands are beginning to disrupt their own business models, brands, and product offerings in response to a new breed of challenger brands that innovate fast and take advantage of consumers' growing appetite for newness.
E-commerce players will continue to innovate by adding profitable value-added services to become the platform of choice. Those who diversify their ecosystem through acquisitions, investments, or internal R&D will strengthen their lead.
Automation and data analytics have enabled startups to achieve agile made-to-order production. Small batch cycles will become the new norm as mass players respond more rapidly, achieving just-in-time production and reducing overstock.
So as you can see, all the processes, all the innovation processes that happens now in fashion industry, in light industry, they're all related to automation, to 3D, to computer-aided design system, computer-aided manufactured system, PLM systems, etc. So the first question that we're going to discuss now, the main directions for improving CAD software for clothing. And here I would like to say that the main emphasis in modern design of garments is focused on improving the method of three-dimensional design of the garment, perfection of the system integrated technology of clothes, designing on the basis of use of modern information technologies, and the definition of the system of relation of the functioning of complex CAD software. And all these questions we discussed before in details when we studied about new latest updates in popular CAD programs such as Lectra, such as Gerber, such as Investronica, etc., and Graphics, of course. And in the area of three-dimensional design of garment, we have, again, several ways of improvement. The first one is 3D dummy or 3D mannequin, which we discussed in the last lecture. And the second one is 3D virtual model of clothes, 3D printing. So I just put here some examples of 3D printing. Cosiflex company and Iris van Herpen, still a young designer. And the last one is wearable technologies. If we speak about wearable technologies, in this infographics picture, you can see that wearable technologies can be applied to the garment pieces to help people with several tasks, with several functions that they should perform in their life, in their everyday life, maybe to help customer to, for example, to know about weather outside, to participate in social media, to know the latest updates in Twitter, to listen to the music, to know about how many calories you've burned before in your physical activities. And there are lots of ways to improve this area. And results of developing CAD technologies is protection and body enhancement through artificial second skin, culture-driven wearable art technology and innovation, hyperbody connecting senses and materials, and the fourth direction, fashion takes care, and 5 direction, real or virtual mixed environment. These are actual trends and actual ways of improvement in CAD technologies related to light industry, and some of them are already developed, and some of them maybe we will see them in the future in our ordinary life, in our everyday clothes that we wear. So I want to show here some examples of embedding computer-based technologies into fashion products. The first one is home body scanner. In the US, startup called Naked Labs has launched a smart mirror and connected scale that can build a 3D scan and full health profile of your body. Naked body scanner consists of a full length mirror with a paired scale that revolves to allow the mirror to capture a 3D model of the person standing in front of it. The mirror designed by Boxclever company works by using 3 infrared-based depth sensors to capture images of the body, similar to those used in now discontinued Xbox Kinect. Naked processor then stitches the images together into a 3D model, accurate to within 15 millimeters. To calculate body fat and other metrics, it runs a proprietary algorithm. So not only 3D model of body you can have using this home body scanner, also you can calculate body fat and other metrics. So here is the example. So this is the scale, and this man through a smartphone can have the results of the 3D scanner, and the mirror works as a 3D scanner. The second, another example of 3D technologies, embedded technologies, is responsive leggings. This responsive leggings by tech brand Wearable X use gentle pulses to give instant feedback to the wearer on their yoga postures. The Nadi X leggings has 5 sensors embedded into the fabric. This connect via Bluetooth to an accompanying smartphone app to determine what yoga position the wearer is in. And I would like to show you some short video about it. You can see the sensors embedded into the fabric. So the system integrated technology of clothes design on the basis of use of modern information technologies, that's smart product design and production control for effective mass customization. And how this works in a industrial scale. The order comes to the manufacturer through computer, of course, and from warehouses material demand, and from product warehouse delivery schedule. Again, it works as a connection in connection with orders. And product schedule goes to production line from the orders received to the computer, goes to assembly workstations, and goes to 3D printing if needed. And so factory system works like the big organism, as you can see. So this is the scheme of PDM, production data management in progress. In the smart factory planning, we can see the system of relation of the functioning of complex CAD software. So again, the main database in the production chain consists of data of production line, of warehouses, of assembly workstations, of 3D printings. And it forms Internet of Things, the big data that consists everything related to the process of production, of manufacturing different type of products. So what do you think? What are the main directions of improving apparel CAD software? The first direction is, what is wearables? Wearables, we studied about wearables maybe a couple of minutes ago. Wearables are on-body products such as clothing, footwear, accessories, and jewelry designed to create a communication, interaction enabled by technology such as digital and virtual to amplify and extend natural ability and performance of the human body, or add new functions to the user, connecting him with his body, with other persons or objects, and with the environment. And I have shown you some examples of how we can use wearable technologies in clothing. Smart textiles. Smart textiles are knitted, woven, non-woven fabric systems designed to sense and respond to external stimuli: mechanical, thermal, chemical, biological, magnetic, and electrical, enabled by advanced physical and digital technologies. And I have shown I've shown you some examples of wearable technologies and smart textiles in yoga pants and smart yoga pants. We have many examples of smart textiles nowadays, and maybe you studied about it on your own. Digital manufacturing. Digital manufacturing is an integrated approach to manufacturing that is centered around a computational system using tools such as 3D technologies, robotics, L&R, and the integration between digital technologies for manufacturing processes and embedded digital technologies and product services to enable open and distributed manufacturing that can reshape design, production, distribution, and retail processes. The extent of applications ranges from the large-scale industrial systems, Industry 4.0 and DUI Mini, and microfactory up to digital service platforms and bottom-up innovation processes, on-demand manufacturing, collaborative and on-site manufacturing, fab lab and makerspace, and repairing and remanufacturing systems. So digital manufacturing, it is the future to what we will go and we will come in the end. The second question is CAL's technology in the production of clothing. What is CAL's technology? CAL's means continuous acquisition and life cycle support, or IPI, information support for the product life cycle, is a concept combining the principles and technologies of information support for the product life cycle at all its stages, based on the use of an integrated information environment, uniform information space, that provides uniform methods, process management, and interaction of all participants on the cycle. So who can be the participants of cycle in light industry? Customers of products, including government agencies and other agencies, suppliers or producers of products, and operational and repair personnel, implemented either in accordance with the requirement of the system of international standards, regulating the rules of the interaction, mainly through electronic data interchange. So here we have three big players in this, I would say, maybe market, like information technologies market. Customers of products, suppliers, and operational and repair personnel. So what is PLC, product life cycle? Product life cycle, we start with design, and then we go to manufacturing, and then we go to distribution, and products go to customer, and after using product, it will be end of life, and maybe recycle or redesign of products, and then again go to manufacturing. So it's a big life cycle of product that will never be stopped by its end. You know that the latest trends in any manufacturer, especially in light industry, is to reuse and redesign products. This is one of the main trends. In order to get a truly integrated solution combining development, production, and supply, it's necessary for businesses to link a basic automation system that includes application software packages for management tasks, tools for integrating tasks into required configuration, interfaces with other systems with CAD. So some CAD systems are now equipped with PDM modules. PDM means product data management, to gather and to make all these processes work in connection. If we think about future of automation in fashion, here again some small infographics that show us the future of production, of life cycle, maybe of consuming process of products of light industry in the future. So, for example, customer wants a dress for an upcoming party. Then customer inputs her style preferences and measurements into the computer. Then the computer synthesizes customers' preferences. Let's say it's Sarah, the name of the customer, and big data signals digital behavior, trending styles, past e-commerce, learning. So everything goes to the computer. Sarah's as a customer, preferences, and big data signals. Then the customer uses augmented reality fitting room to try on dress options and select her favorite. Then it goes to the computer again, and 3D platform renders dress, tailors, to customers' measurements. Then robotic sewers and cutters assemble the dress. And after that, ready-to-wear dress a customer can wear to the party and can go to the party in her or his new clothes. It's a quite impressive process that awaits us in the future. At least we hope so that it will be like this. But if we think about fashion, is everything in fashion industry will be automated in the near future? Of course not, because we have some greatest examples of high fashion that maybe will never go away from us. So here we have production process. In House of Dior. Where 80% of work should be made by hand. And the product itself. That is everything that I wanted to say for today. If we summarize that everything that we learned today, I can say that latest technologies allows us to think that in the future, light industry will be developing in the way of automation, in the way of robotization, intellectualization, and augmented reality, maybe to some extent. But some of the old school styles, some of the old school works, as for example, embroidery or high fashion standards, we hope that we can see such things in the future as well. Not only robotics things, not only 3D things, but something that's still made by hands. So we have some questions to discuss. You can think about it later on. And here we have some small glossary related to the topic artificial intelligence, AL, augmented reality, DUI, do it yourself, and Internet of Things. More information you can find here. Don't forget to hand in individual work made with the lecturer and individual work of a master degree. Number 2, if you have any questions, you can ask through WhatsApp. Thank you for attention. Thank you for participating this lecture, and see you in the practical lessons.